Hi guys, today we're going to talk about lesson 2.1, which deals with multiplying numbers and expressions with exponents. So we're going to talk about the properties of exponents here. We'll start out today just talking about multiplying things together. We're kind of focused on two things. First, what does it mean to multiply expressions with exponents? What do those exponents mean? What do they represent mathematically? And then secondly, to talk about what are the rules for doing that. So what are some of the shortcuts that we can use and some of the rules that we can derive from some examples here. So here is an expression with an exponent. We have 2 to the third power. So this is 2, right? Is the base number. We call that the base. And then 3 is our exponent. So 3 is our exponent. We also call that a power. Right? So 3 is our exponent or a power. Okay, so what this means, it just simply means we're going to multiply that base together the number of times it says in the exponent. So in this case, we're going to multiply 2 together 3 times. So this means 2 times 2 times 2. Okay, so it's the base multiplied together the exponent number of times. All right, we use a lot of sort of nicknames for these exponents. When it's an exponent of 2, we'll call that squared. If it's an exponent of 3, we'll call that a cube. There's some other ones that we'll talk about as well, but those are just kind of shorthand, and exponents themselves are just shorthand for multiplication. So 2 multiplied together 3 times. And when we're talking about numbers, right, we have a number that's raised to an exponent. Generally, we don't write that as just a number to an exponent, a base to an exponent. If it's a number and we can go ahead and figure out what that is, we'll write that out. So in this case, 2 times 2 times 2, that's going to be 8. So 2 to the third power is 8. So here's another example. I have 2 to the third power times 2 to the fourth power. So I have 2 multiplied together 3 times, and then that multiplied by 2, which was multiplied together 4 times. So if we were to write this out, if we didn't have exponents, we would have to write this out as 2 times 2 times 2. That's 2 to the third times 2 times 2 times 2 times 2. So 2 to the fourth. So this is 2 to the third times 2 to the fourth. And you see how many times we're multiplying 2 together. 1, 2, 3, 4, 5, 6, 7. So we have a total of 7. So this is part of the reason why we use that exponential notation, is just so we don't have to write out these kind of ridiculously long, hard to read, hard to write expressions. So our shorthand for that, we would say that that's 2 to the 7th. And again, if it's a number to an exponent, we typically want to expand that out and say what the actual value of that is. So 2 to the 7th is, if I just think about 2 and I multiply that by 2 every time. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. So that's 7 2's multiplied together, that's 128. So if I look at this on a calculator, and let's see, I'm going to share my whole screen here. So I look at this on a calculator. So I just have the Desmos graphing calculator up here. So it works pretty much the same on any calculator, but sometimes you use a special character to get that exponent in there. But if I wanted to do 2 to the 7th, I would say 2, and then here's my exponent, and then I would go 7. Okay, so 2 to the 7th is 128. All right. If I were going to type that in, I would say 2, and then I'd use the little caret symbol. So the little caret symbol like this. So I would type in 2, and then this symbol right here, and then 7. So that typically means 2, and then this symbol means exponent and 7. So I could actually just type this in from the keyboard. I could say 2 to the 7th, and it would type that in for me. Okay. On your calculators, if you have a TI calculator, Some of them will have an exponent like key, some of the newer ones will, but the older ones will just simply have like a little caret kind of key on there that means exponent. So, so 2 to the 7th. Okay, so here's some definitions that you can look at, and some of the powers. The product of powers is what we call that, what we just did. So we talk about base and a power. 2 to the 3rd, 2 is the base, 3 is the power or the exponent. That's 2 to the 3rd power, or we might say that that's 2 cubed. Product of powers, that just simply says that when we're multiplying powers together, right, when we're multiplying things together that have the same base, that we can just simply keep the base and add the exponents. So if I had 3 to the 2nd power times 3 to the 7th power, well, I could actually, instead of writing that out as 3 times 3 times 3 times 3 times 3 and all that, I could just say, well, it's 3 to the 2nd power and 3 to the 7th power. So I'm going to have 2 3s here. I'm going to have 7 3s here. I'm going to have a total of 9 3s altogether. So I can just add those exponents together. They have the same base, right? So I can just add the exponents. So this is going to be 3 to the 9th. Okay, and that's what we're going to really focus on today, is that product of powers, right? So what are some examples of that and how does that work? Okay, so let's take a look at these. So I'm going to pause the video here and I'm going to ask you to fill these out, and then I'll show you what that answer looks like when we come back. Okay, so if you tried these on a calculator, right, you might get some different results depending on your calculator and depending on how you typed it. But we have to keep in mind, like, what does this mean? And this is a very ambiguous way of writing this. This is not really a good way of writing this, but you'll see it written like this more times than you can imagine, and it typically will throw people. What this means is order of operations, we do parentheses and then we do exponents. There's no parentheses here, but this 2 is our exponent. And what's being raised to the 2nd power? Well, in this case, it's just the 3. 3 is what's being raised to the 2nd power. The negative means -1 times that, or the opposite of that. So this is the opposite of 3 squared, or -1 times 3 squared. So in this case, we would say this is -1. That's not being squared, but the 3 is being squared. Okay, and so in this case, I do order of operations, I do the squared first. So 3 squared is 9, and then times -1, that would give me -9. Now, this example down here is much clearer because it says, I want to take all the stuff inside this parentheses and square it. So this is -3 squared. Okay, so it's negative times 3 times negative times 3. I get negative times negative gives me positive, and 3 times 3 gives me 9. So I get positive 9. Now, a much better way of writing this expression, right? If I wanted to do the opposite of 3 squared, what I would really want to write that as is this, -3 squared. There's no ambiguity, okay? I'm going to do order of operations. I'm going to do the 3 squared first, and then I'm going to take the opposite of that or multiply it by -1. Okay, so this is not really a great example of how to write these out. This is a better example, and then this example is also good. If you mean -3 squared, right, you want -3 times -3, this is the way to write it. And as you start typing math, that way of writing those and typing those is really important, because if you just type this into a calculator, you'll get -9, and that may not be your intention. All right. Okay, so we'll talk a little bit about the kinds of like polynomials that we're going to talk about. When we talk about polynomials, polynomial just refers to the number of terms in an expression. All right, so we have 3 of them that we're going to focus on here. There are other ones, but they're not really widely used. But we call them monomial. Okay, a monomial is just an expression that has 1 term in it. So for example, 2x. 2x is an expression. It's got 1 term, Remember, the term is the things that are multiplied together. So 2 times x, that's one term. So 2x is a monomial. 5, also a monomial. We'd call that a constant. There's no variable in that. There's no letter with that. It's a constant monomial. And then this one, we would also call a monomial because it's things multiplied together, right? So multiplied together. So that's just a term. And so this is a single term right here. That is x cubed y. So that is one term. All right. When we have two terms, the way that we tell the terms apart is we add or subtract them from each other. So things that are added or subtracted together are what we call the different terms. So this one has two terms. It has x is one term and 1 is another term. So this is two terms. Same thing here, a and b, right? If I had two constant numbers, 2 plus 5, that would also be a binomial expression, right? Two terms. And then c squared minus c, also a binomial. Okay, remember back to algebra, we talk about combining like terms and how c squared and c are not considered like terms. So they have to be the same base and the same power in order to be considered terms or like terms. And so monomial means one term, binomial means two terms, just like a bicycle has two wheels. A trinomial is three terms. So a tricycle has three wheels, a triangle has three sides. A triangle has three corners, right? And then a trilateral actually has three sides, but they're kind of the same. But anyway, you see here, I got 1, 2, 3 terms. Okay, so that's a 3-term polynomial. And here we have another 3-term polynomial. All right, so hopefully these terms are this terminology is a review for you, but that's what we're talking about. That whenever you hear this nomial, right? Nomial just means how many terms are there. There's 3 terms, 2 terms, 1 term. When we get beyond 3 terms, we just simply say a polynomial with 4 terms, or a polynomial with 5 terms, or a polynomial with 6 terms. But when we talk about those first 3, 1 term, we call it a monomial, binomial, and a trinomial. Okay. So is this a monomial? So I'm going to go ahead and pause the video here. I'm going to have you respond to some questions about these, and you tell me yes or no, is this a monomial? Okay, so come back here. Is this a monomial? Yes, this is a monomial. Single term, that is a monomial. Single term, this is a monomial. Single term, 3 times x is still a monomial because we're multiplying 3 times x. We're not adding 3 plus x. Is this a monomial? No, this is not a monomial. This is a binomial. Okay, 2 terms, 3 plus x, this is a binomial. 3 divided by x, yes, that is a monomial. So that would be considered 1 term. Multiplication and division is considered part of 1 term. So this would be a monomial. This would also be considered a monomial. Okay, it's just a bunch of stuff multiplied together. That's a monomial. This one right here, we have 2 terms. We have that addition or subtraction in between there. So that is actually 2 terms. So that is not a monomial. That would be a binomial. Okay, and then this one, I could actually write this as x over 2 plus 1/2, right? So even though it's x plus 1 divided that, we have that addition in there. Because we have that addition in there, that makes it 2 terms. So this is not a binomial. Okay, that is not a monomial. It is a binomial. And then the last one is a little bit of a trick question. And the reason it's a trick question is because this last expression here is not in simplified form. Okay, the way that it's written right here, it's actually a binomial, x minus x. But generally, we wouldn't leave it like that. Okay, if we have 2 like terms here, we want to combine those and simplify that. So if I had x minus x here, that would equal 0. And so when I simplify that expression, those x's go away. I'm just left with a single constant 0 that is a monomial. Okay, even though 0 is nothing, right? It's still a single term, and we would call that a monomial. Okay, so I'm going to go ahead and pause the video here and let you take a look at these. Remember that we are simplifying these expressions, and when we have numbers, that means that we want to go ahead and expand those out. Okay. Okay, so if I do 4 to the 5th times 4 to the 3rd, they have the same base, so I'll add the exponent. So this is going to be 4 to the 5 plus 3 power. 5 plus 3 is 8. That's going to be 4 to the 8th power. Now, I'm not going to try and multiply all that out, so I'm just going to use a calculator. I'm going to say 4 to the 8th power, and it's going to tell me that's 65,536. All right. The second one, this is 3 times 3 to the 6th. We can think of that as 3 to the 1st power. And so we can apply our little rule here, our product of powers. And so when we have the same base, we can add those exponents. 1 plus 6 gives me 7. So this is 3 to the 7th power. And 3 to the 7th power is going to be 2,187. And then the last one, this is kind of a trick again, okay? Think about what we talked about before. If I were to expand this out, this is negative times 2 squared, right? Negative 1 times 2 squared. 2 squared is 4 times negative and then 2 squared. So this is also going to be times, whoops, negative 4 times negative 4, okay? I'm sorry, I did that wrong. Negative 4, okay, and then this is 2 to the 3rd power. 2 times 2 times 2 is 8, right? And the opposite of 8 is going to be negative 8. So this is times negative 8. I almost messed that one up. All right, and so when we multiply, negative times negative gives me a positive. 8 times 4 is 32. So in this case, we get 32. Okay, here's some other ones for you to take a look at. I'm going to pause here and let you work on those, and then we'll continue here in a second. Okay, so when we look at these expressions, this is 3 times k to the 4th times k to the 2nd power. So I'm going to multiply all the numbers together. 1 times 3 is 3. And then I've got k to the 2nd and k to the 4th. So k has the same base, and so I can add those exponents. This is going to be 3 times k to the 6th power. Okay, and I don't know what k is, so I can't evaluate. So all I can do is simplify that. In this second one, I'm going to multiply the numbers together. So I have 3 times 4 is 12. And then I have x to the 4th times x to the 1st. So this is going to be x to the 4th times x to the 1st, x to the 4, and then 1. So that's going to be a total of x to the 5th power. And then the last part, I have y squared and y 7th. So add those together. That's going to give me y to the 9th power. And then the last one, you know, this looks kind of scary. There's a lot of stuff going on here, but break it down and just do each variable independently. So I'll do the constants here. I'll do the number. 6 times 2 is 12. And then I have a squared and a to the 3rd. So I have 2 plus 3. Whoops, 2 plus 3. That's going to be a to the, let's try that again. A to the 5th power. And then for the b's, I have b to the 2nd power and b to the 7th power. 2 plus 7 is going to give me 9. So it's going to be b to the 9th power. Multiplying b together 9 times. And then I have c to the 3rd and c to the 9th. So that's going to give me c to the 12th power. 3 plus 9 gives me 12. Okay. And again, these are all expressions that have variables in them, so we can't actually evaluate them. All we can do is simplify them. Okay, so here's your assignment for tonight. So you're just going to do homework 2-1 on Canvas. There should be a printed version there too. So if you prefer to print out your assignments and do them on paper, you can do that. Don't forget to send me photos or scans of your work. All right. If you're doing the paper version, okay. If you're doing the online version, please get in the habit of putting that work in your actual assignment itself. Okay, that's a good habit to get into. It's a good practice to learn how to type math, and especially when you start getting more complicated expressions and complicated math operations. It really helps to write those down and to have a good log of the work that you've done. All right, I'm going to go ahead and end the video here. I hope this is helpful. Please let me know if you have any questions.